Well, hi, good morning. Thanks so much for joining me in my shop today. Another fantastic day here of 100% sunshine and cool air. So just beautiful. So once again, I don't want to be down here too much for too long. So now I've pretty much accepted that the two vibrators that I have. What's the problem with the video? What's the problem here? Hey, video. Hey, video. That's better. Oh my gosh. Shadow. Shadow. Remember, Shadow used to run around on my bench while I was working, but she's too big now for that. Shadow. Okay, well, I know what she's after. She wants to go outside. I have to go let her outside. Okay, cat's outside. Video camera's unfrozen. Great, now we're ready to go. So what I've given up on the, or I've reached the conclusion, that's a better way of putting it, that the vibrators are not going to work. The two vibrators I have for the two radios I have, one of these guys. So pretty sure we'll be ordering some solid state replacements for those. In the meantime, what can I do with a radio that cannot produce any high voltage? And the answer is I can produce the high voltage for it. So what I'm hoping to do today is to actually operate this radio, and because it can't produce the B+ voltage in its own power supply, I will just use one of my shop supplies and punch it in there. First, I better take a look at the schematic and just see if this is really reasonably possible here. Let's take a look. Okay, so here's the schematic, and the area we're interested in is all down in here. And the vibrator, step-up transformer, rectifier tube, output from this whole thing is on this one wire. It even says right there, that says 225 volts. 225. So all I have, and let's see, this wire goes back just to the cathodes here. So in fact, if I pull this tube out, that will ensure that this is doing nothing. I can just pump in on the on this wire, which I can pick up in a few places, but this is one good one right here, right on the cathode. Pump in the voltage, and this radio should operate. I still need to supply the 6 volts to run the heaters, but they appear to be coming on. And you know, that should give us a pretty interesting result. Oh, look at the information here. 10.7 volts at grid for 1 watt output. Interesting information here is the gains of each of these stages: 18, 28, 15.5, and I think that says 55, I'm not sure. What else is on this schematic here? Okay, so the intermediate frequency is 265 kilohertz. It's a little bit unusual. Okay, for resistors, looks like it says M equals 1,000. Therefore 10M is 10,000. So M is French for mille, is for M-I-L-L-E, that's 1,000. So in these older schematics, sometimes M means 1,000. And if they want to mean a million, they put the word meg, M-E-G, right on the schematic. All resistors are quarter watt. Designates chassis ground. Tube sockets are bottom views. Stage gains taken at antenna. Antenna socket, an RF grid. A dummy antenna, battery conditions. 6.3 volts at the battery terminals. So I think this is back at the actual battery itself. So there's a bit of a voltage drop in the wires. shouldn't be much on my shop. 6.3, so it really is aiming, I'm pretty sure, for 6 volts. Volume control set at maximum. Voltages to read from point shown to chassis with 1000 ohm per volt meter. That's an important piece of information right there. This is not the best kind of voltmeter. This a voltmeter with this kind of rating, 1000 ohms per volt. Say you put it on the 100 volt scale, and you've got 100,000 ohms. Huh. So what this means is the readings on the schematic are probably a little low in comparison to what you would read with a modern voltmeter that has a higher impedance. So that's something you always got to keep that in mind all the time. Good. So I think it's a simple thing. Pull this tube, find this pin, hook up the power supply, crank it up to 200 volts or so, and listen to the radio play. Okay, let's try it. So first thing is hooking up to, first thing, let's pull the tube out. These tubes are tricky to get out. I can't get my fingers on it, and they're locked in. These are lockable tubes. So I'm going to try to push it out from below with something that won't hurt anything. What would that be? Just a great big, totally intimidating screwdriver. If I don't push it out, I'll scare it out with this. Yeah. So it's a round thing I'm pushing on. That means my screwdriver is going to slip off and badness is going to happen. That's not going to be good. Try a nice, like a piece. A wooden dowel would be excellent. Okay, how about this? That's better. There we go. Just pop the tube, popped it right out. RCA Radiotron 7Y4. This is a little A6B. And you can see the style of it. See, it has a locking shape there. It locks into the socket, and of course that's, you know, most cars have this kind of tube in it, lockable tubes. Great, so that's out, no problem. You know, if that vibrator is operating and this is defective, I would still get the no B+, I believe. Okay. Now we're going to bring on the power supply here. In this case, since there's not a lot of current involved, let's go back a little bit here. I can use these leads. Now I got to figure out K on that tube, the cathode. The cathode, and the tube was 7Y4. Let's see if I have that. You notice the first number is a 7. It doesn't mean 7 volts. They just didn't want to. They wanted to separate these tubes with a special base from the rest of the tubes, and they thought a good idea was, instead of calling them a 6 something something, they would call them a 7 something something. And then you know if it's a 7, it's a locked. I believe that's the story. 7Y4. So this is liable to say, well, just go see a 6Y4. I've never heard of a 6Y4. Hey. Yeah, 6Y5. So 7. Hey, where's the 7s? Here we are. 7. Y4. I gotta drink some more coffee here. Now you're seeing a big white blank page, but 7Y4. Here it is. Let's see if I can get a little better. Movement there. That's what it says. Full wave vacuum rectifier, glass lock-in type, used in power supply of automobile radio receivers and compact operated receivers. Compact AC operated receivers. Tube requires a lock-in socket. Heater volts 6.3 amps. Oh, half an amp. So we were getting 2.5 amps through the radio with 5 half-amp tubes. So 5 times a half, 2.5. There we go, 2.5 amps. That all makes sense. Peak inverse plate volts, 1250. That's a pretty strong tube. Okay, so what's the deal here? The deal is I want to figure out where the cathode is. Pin number 7. Pin number 7. Pin number 7 right there. Didn't get a good view of that, but that's okay. Pin number 7. So I look in here, get my clip lead ready. Ooh, where do we start counting with this tube? Okay, so there's a key. Okay, let me just change the lighting in here a little bit. It's so bright, we need more light. It's kind of counterintuitive, but adding more light causes the video camera iris to close up and gives you, anyway, one thing here. So there's a key here, so we can assume that is pin number 1. So can I see the key? Can I see the key? The key doesn't descend all the way down through the bump. So I actually cannot see it. Cannot see it from below. So looking from above, this is the way the tube goes in. Okay, so you can see the key is right on the bottom there. Bottom pointing straight down. Straight down. You look from the bottom here. Well, you can see it if I kind of, yeah, if I kind of look through like this, I can see it there. So that makes pin number 1 that one. Did you get that? But that's not the pin I'm after. The pin I'm after is left my head. You know, like I have a pin number in my head here, but I know how I am, and I tend to get this stuff all mixed up, so I better look again. 7, because I don't want to make a mistake. 7Y4, right? 7. I'm even saying it. 7. Now this is a negative grounded, positive grounded radio. Does that mean I'm actually, oh my god, my head is all turned around here. How do you get positive onto the plate? By driving the cathode way negative and leaving the plates at the chassis voltage. I just can't believe that's how that's done. Is that how that's done? How? I can't believe that for a minute. So here, looking at just the schematic, just looking at some of the ground points. Yeah, here's a ground, goes straight up to the cathode. So you know what? It doesn't matter that it's negative or positive grounded from the car battery, because this guy is producing its own internal voltage. For sure, this has got to be positive to the chassis. I mean, the tubes can't work otherwise. So, okay, momentary anxiety unnecessary. So, counting number 7. Here we go. Let's see here. 1, 2, 3, 4, 5, 6, 7, and one more is 8. So this is 7. And this is the guy that we want to energize. sure this clip lead doesn't wander. There we are. Good. And we'll just clip this right onto here. Okay, now if there's a problem in the radio, we're going to see it on these meters up here. We will. This is actually a very useful test. I do this with a lot of radios, even ones that, certain not car radios or anything like that. Let's get our meter ready. There we are, zeroed up, ready to go. Power still connected. Switch is off. Okay, so with the set off and with no power going to the heaters, we're going to raise up the voltage in the radio, make sure that this connection actually is working properly before we get too far into it. Let that warm up for a moment. And I try to do most of my work with vintage equipment, also vintage repair equipment. And all the vintage repair equipment has its own problems. So, not that there's anything wrong with this power supply. So the way this is going to work, a little better view of the meter here. To keep an eye on this meter here, but it's just not gonna. Let me switch the lighting again. It's a little better. Okay. Well, once again, just check everything. Everything's okay. So this meter is going to show the voltage. It's very hard to see in the camera, isn't it? So we just get a little better there. This will show the voltage that we're applying, and this will show the amount of current running into the radio. This should stay extremely low, even show pretty much at 0. It may pop up a bit as I turn it up. So here we go. We're going to aim for 100 to start with. See what happens. So I can see the meter popping up. Those are capacitors charging. So we're going to get up close to 100 here. Well, 100 on this meter, 100 volts. And we've got, a little bit of a current flowing there. This would be, it's slowly dropping off. So I think we're probably charging up a few capacitors that may not have been charged up for a while. Okay, now we want to run the radio up at 200. Let's give it a moment here. Okay, let's head up for 200. If this meter should rise up in the area of the red line there, that's danger for my power supply. So something may break down or explode. Very, very slowly. I'm also listening. So are you. And the microphone you're listening to is right above the radio. I'm not listening for the radio to work. I'm listening for stuff to break down, snap, crackle, pop. So as radios go, this is a pretty high leakage I'm seeing right now. Let's leave it there for a minute and let it. Yeah, that is a pretty high leakage. Typically when I'm doing this on radios, this meter is barely off the 0. So in fact we are now running 10 milliamps at almost 200 volts. So 10 milliamps at 200 volts. So that's 10 at 0.2. It's 0.2 times 10 is 2. About 2 watts of power being dissipated by the radio here. 2 watts concentrated in a little spot would make smoke come out. So the question would be now, can we operate the radio like this? With this the current draw is going to increase on this power supply. When the tubes are energized, each one of them is going to conduct a quiescent current. It's going to conduct a steady current. Every one of them would be 5. Yeah, 5. Count them 5, because number 5 is actually there. 4 tubes drawing, I don't know, maybe 10 milliamps of current through them. It's another 10, 20, 30, 40. I'm just going to put this way up in here. I don't know. I don't think that's quite normal. I think that's just a little high. So what I could do is I could actually power up the heaters right now with no reason for me to shut the voltage down, but I am. I'm going to shut down the voltage here. Okay, and we're going to switch over to the... That's the supply there. That's going to feed it power. Okay, switches off on the radio. That's 5 volts coming. I'm going to put a more accurate meter on the B plus here, so we can keep track of it. The meter that's on the instrument itself is kind of crummy. Don't put that there. Put it here. And positive 1. Now there's a better way of doing this. I'm going to put this up. Well, I was going to say I'll put it up at the supply, but maybe not. But this wire, maybe I better keep it down here. How am I going to do that? Where am I going to clip this? We're going to take some momentary readings, I think. Can do that. Okay, that'll work. We just kind of double check the voltage coming to the radio. The radio's still off. We can do that now, actually. So keep an eye on that meter there. It's on the 500 volt scale. So we're expecting it to come roughly in here. This is just to make sure. And then once I've done that, I've sort of calibrated the meter on the... This isn't zeroing. Okay. Okay. There we go. Quite a current flowing into the radio now, so that's not even 200. That's exactly 200. That is 200 on that meter. 200, and on this meter it's exactly 200 on this one too. Good. Okay, so much for me saying that meter's lousy. 200 volts on here, and a pretty good current flowing here of 20 milliamps at 200 volts. Wow. It just seems high. High. Okay. Yeah, it could be these. Can't be these. These are not in the circuit. Okay, let's carry on. Oh, there was another matter here. Another matter here I have to sort out. The matter is something I noticed last night when I was in here, that this plug for the speaker may actually be wired incorrectly. It doesn't quite match what, pictorially what is shown on the schematic, the way this is done. But there's 3 pins on this plug, and you got to hook the wires up to the right too, and I don't think that's what's happened. So we're gonna try to energize the radio, listen to the speaker. If there's absolutely nothing coming out of the speaker, no hiss, no crackle, no hum, nothing, then this is probably wrong. and we'll pursue this a little bit further. I'm so close to trying to energize the radio, we might as well continue. So close. Okay, in fact, let's get the speaker out here so I can lift it up. Oh, that's tricky here. I'll be able to lift it up to as high towards the microphone as I can, and that's not going to work, I don't think. Yeah, it is. It is going to work. Have some faith, Jim. Oh, for crying out loud. Goofy situation that was. Okay. So what I'll be able to do is literally lift the speaker up to the microphone, and you'll be able to listen to it also. Listen right now. Sounds of the ocean. Okay. And we still have our DC meter here too. Okay, B plus is set to low. Turn on the heaters. Don't need to watch that meter over there because we know what it's going to do. Here we go. Heaters are on. See the current flow? See it leap really high there for a short while, and that's because the heaters were cold. Once the heaters warm up, they resist the current a little more. So we're not 2.4 now, we're 2.1, and that's because here's the 0.3 or 4 here. This tube is out. So the heater's not in there. Everything's making sense. Okay, I'm going to turn it up. I'm going to start applying B+. And do I dare hold the speaker in the air while I do that? The reason I say that is because, you know, there's a couple kinds of accidents you get from electricity, and one obviously is the shock itself, but the other one is the dropping of the stuff, the falling over, or the throwing of the stuff. So, you know, anytime you're picking something up, I'm sure it's perfectly safe to do this. So I'm going to hold this guy up here. Volume's up full. Here we go. Add some voltage now. I'll read it out to you as we go. Okay, about 100 volts. Hey! There we go. Get it out a little more. A little more. 120 volts. I don't need to hold this up to the microphone, do I? Well, here we go. Oh, what is happening here? So in my shop, an AM radio is bound to pick up lots of interference sort of sounds, but they aren't crackly, staticky, crashing sounds like that. It's sort of hissy and there's a bit of chugging in there. That's just noise coming in on the antenna. And where is the antenna? The antenna is still connected to the signal generator here. So, in fact, what about putting a better antenna on here? So, good. Leave it like that. Let's tune this thing and see what happens. Huh. So the B plus current draw is still 20 milliamps. It hasn't gone up. I said something in the last video about reluctance. Oh, something just changed there. Okay, I don't know what happened there, but it seemed to me it just suddenly picked up and yeah, I'd mentioned something about reluctance tuning, you know, putting the slug through the coil. Where's the camera? There we are. resulting in a really nice linear dial. No, this is terrible. This dial is terrible. Terribly non-linear. Okay, we're getting down to where there are actually some stations. What was that? It's my meter down here. Beeping at me for some reason. Okay, we still got 20 milliamps. Now, if we actually pick up a station, I'd be kind of surprised. Because there's really no antenna on this. It's very good at picking up the noise in the shop. Let's put a little better antenna on it. See where that gets us. This is terrible. Piece of wire here. This is not what I want to do. It's a very short additional piece of wire. There goes my meter. I've got just a couple feet of wire hanging out there. It'd be somewhat similar to a whip antenna, in fact. Something right there. How good's your hearing? Interesting. Okay. Wow. Very good. Wow. Okay. Do we dare push one of these buttons? The buttons will engage the motor drive. Oh, also, that proves the speaker connections are correct, by the way. So much for what I was thinking. Why wouldn't we push this button and engage the motor system at this point? He asks wistfully. Okay, here we go. I'm pretty sure push this one, the motor drives it this way, and you push this one, it drives it that way. Let's go that way. You see the pointer in there? There we go. Well, it just shot right over. Let me get a little better camera on here. This is one of the super features of this radio. And I have no real familiarity with it. That's soon to change. Now you can see what I meant by non-linearity there. It's all really jammed up in the top here. Okay, so I'm going to push this button, this one right here. You know, both buttons rotate at the same time. So maybe I've misinterpreted how this works. This would be the driver's button and the passenger's button. Yeah, could be. Let's try the other one. Wow, it knocked the volume right out, and then the volume slowly came back. So what's happened with this thing? M. So this is set to M. This is set M for manual. How do you get it off of M? One more push? Is that what's been happening here? No, I didn't change it. Knocks the crap out of the volume. That's maybe on purpose. So the radio goes quiet while you're tuning. Let's see, now I can this button over here. You're supposed to be able to pull this up. And then what? I don't think there's anything going on there. So apparently I don't understand what I'm doing here with this. So this should be going 1, 2, 3, 4 M, I believe. Let's try it again. Okay, so I got to find out a lot more about the how that mechanism works, because it's not working here. You know, I got another radio. Should I just pop that other radio up here and give it a shot? Why wouldn't I try that? It's just a matter of connecting the whole thing up just like this one. Okay, so the B plus current has remained, it's actually fallen a little bit. It's about 15 milliamps. It's good, I think it's all pretty good. Okay, now let's power this guy off. That's the best way to power it off. Hey, there was a light in there. The light is lighting. I guess maybe a little bit of light gets down into these, so at night they light up. Good. Okay, high voltage. Good show. Okay, now the easiest way would be to bring the other radio. You know what? I got to take the cabinet off the other radio and everything. So I'll do that all off camera. See where we get. Okay, I'll bring in the other radio. Okay, here it is. I've taken the screws out already, so yow! Woo, baby! So this one has not been worked on by anybody. It's full of all the original. Hey, the cover's missing here. Huh. Surprise. Yeah, I gotta wonder, how can the cover be missing and yet no one's done any work in here? So yeah, all the capacitors are original. Woo-hoo-hoo-hoo. Should we fire this guy up? I'm going to do it exactly the same way. Let's flip it over here. Wow. Whew. That's one mighty dirty radio. Wow. Got a wire here that's exposed. It's down far enough it shouldn't short against the cabinet, but you know, how would that happen? And dirty, dirty, dirty. This is one really dirty radio. Okay, I'm going to pull out that rectifier tube just to make sure. There's really no reason to do this, but oh, I can't pull it out. I have to push it out. Push it out. Wow, that's really dusty. Let's, you know what I'm going to do? I'm going to utilize my new shop vacuum and vacuum this guy out. So, let's see. I'm just going to cut the microphone volumes down while I do this. Just going to take a second. Okay, that's my new $1 shop vac. Picked up at a yard sale on the weekend. Let's see if we can pull this guy out. Can we really pull him out? I really cannot. Don't really have to take it out, but I want to anyway. There's that pencil I used last time. Get my hand back here to catch it when it comes out. Okay, so this one's not going to leap out. Hold still, radio. Battle 7Y4. Good backup set of tubes in here. Piles of dirt down there. We're going to leave it for now. I want this just the same way the other radio is. There we go. Okay, and we're gonna transfer everything here. There, getting a little hot. Okay. Ground. Okay, this is the DC supply. This is going in without a fuse. And that looks like that's been stuck on the top of a car battery. Okay, so it's positive ground, don't get it wrong. Power supply is on at the moment. It's a bit of a oh, such a painful death. Now, so this would go on here. Turn the radio off. Another little crack in the insulation here. It's good to notice these wire insulation problems when you're first looking at a radio. It lets you know what could be going on in terms of stiffness. A lot of these radios, the wires are so stiff, you can't bend them without shattering the insulation on them. That is one downhill trip if you start doing that kind of stuff. Okay, so we're just going to rely on taking current readings and whatnot to determine if there's a problem here. So, turn this guy back on. DC 0. Okay, so that's ready to read the current flowing into the radio. Switch is off. Now beat plus connection. That was pin number 7. Pin number 7. You know, so I really haven't tried this radio with its I haven't tried this in a normal way with the vibrator in here. Maybe this radio works with the vibrator for some unfathomable reason. Now, oh, here, this is bizarre. Okay, close-up camera time. Try and explain this. How can you explain this? Let's take a look. Okay, so we're looking at this capacitor. Well, you can already see what I'm showing you. Look, somebody Somebody's been in here with a soldering iron far too cold. Look at this. All these. What is all this stuff here? Hey, these resistors are replaced. Well, what kind of value is that? That looks like brown, black, red, so that's 1,000. But any other radio, they're much higher wattage than that. These are low wattage. So I have the feeling whoever tried to solder here just didn't get this terminal hot enough. And then this never got connected back. Well, why all that wire on it? So some things are not adding up here. Now, in the other radio, this capacitor is hooked up to this terminal here. Yikes! Yikes! Okay, but all this is behind where I'm injecting the voltage. So even if there are problems in here, it doesn't matter, because I am going to bypass it all or jump beyond it all. Now I just got to figure out pin 7. So pin 7 is this one here. Make sure there's no shorts in there. Looks good. So we'll follow the same procedure, and in energizing this, first we'll just add a little B plus and see what kind of current flows on the B plus circuits. And okay, so let's just review quickly. Okay, DC power supply, positive grounded. B plus supply, negative grounded, positive onto pin 7. Clamp on ammeter on the supply wire. Speaker's not plugged in. We're not going to get too far without that. Speaker's not plugged in. Come on, baby. You're gonna tell me you don't fit? There we go. Hopefully that's in good enough. Okay, once again, can we raise the speaker? Yep. Okay. Down, and antenna connection here. Okay, we have the same setup now. Who knows, will this radio work? So first test B plus and current leakage on B plus. So we want to be looking up here. Watching this meter. Man, this one got up to about 20, 15 or 20. Ooh, shame on me. So I'll start turning it up. We'll watch what happens here. Okay, so we're at 50 volts. Okay, so in this radio, let's see, we're getting up towards 100. Let me let it sit like that. We're at 75 volts. At 75 volts, this is drawing the same current that this one drew at 200. Well, actually, it's dropped off a bit. Let's go a little further. The other radio came to life at about 100 volts. So we're not going to get there with this radio, I don't think. I'm trying to keep this below 25 milliamps. Quick calculation. 100 volts, 25 milliamps. 100 volts is 0.1 k volts. 0.1 times, what did I say, 20? 2 watts. Still Not very much power. I'm thinking more about my supply here when I... Woo. Dirt in my control. Okay, so we're at 100 volts. Okay, I think we can probably get there, and the radio's going to work or not. Switch was off for all that. Don't think it matters. So the next thing is putting power into the tubes, into the tube heaters. Remember, the rectifier tube is yanked out. Okay, switch is off. Confirm just over 5 volts. Switch on, and I'll watch this meter. Whoops, can't watch it. Don't watch that one. Watch this one. This meter, remember, last radio was around 2 amps under these circumstances. That's a no B+, just tube heaters, 1 tube pulled. So this should come up to like 2 or 2.1 or something like that. Unfortunately, I can't turn the supply voltage any lower. I certainly would if I could, but I can't. So it's all at once. All right, we're ready. Here we go. Watching, standing back. Well, okay, that's just a little bit disappointing, isn't it? How come nothing? How come nothing? They don't usually like nothing. Nothing whatsoever. That's also hard to explain. The heater circuits are simple and pretty solid. Is there a fuse hidden in here somewhere that I... The other radio has a fuse. This one doesn't. This is probably a slightly older version, and they introduced the fuse later on. There's no use putting unless I got this wrong. DC. I can't see how this is wrong. Maybe this didn't make contact. Snappy click. No. On-off switch not really on. On-off switch not working. That's a very high likelihood. The on-off switch just is not actually turning it on at all. Well, that's a little disappointing. The tube heaters are all in parallel, so if one of them is burned out, that shouldn't stop the others, unless they're all burned out. How could that possibly be? Somebody put 120 volts onto it, that would do it. Even if you hook this up to a 12-volt car battery, I'm not sure it would pop those heaters instantly. We should pop one of the tubes out and check for heater continuity. I don't have to pop it out to do that. Okay, so switch is off, power off. Let's pull this off too. Pull this one off. Okay. So we're going to look for do this without popping the tube out. That's not going to be easy. I have a tube popped out, but it was not in there. Let's pop another tube out. Pop this one out here. Jeez. Always exciting in the shop. Wow, these are much harder. Okay, maybe there's one I can get my fingers on easy here. Just okay, I got one. So the idea here is if the heater is burned out on this tube, maybe it's burned out on all of them. Not much of a chance. Roger's Majestic. 7C5. 7C5. 7C5 beam power tube, yeah. Heaters are 1 and 8. 1 and 8 either side of the key, I think. 1 and 8. That's how they've drawn the diagram. So we see the key, 1 and 8. One and 8. 1. Actually, that's 8 and 1. Okay, 0 resistance. 2.5 ohms. So I think that's probably proving that the heater is good in this. So what's going on with this radio that it doesn't want to take any power? You know, the next suspicious thing is the on-off switch is not working. From here, it's really a matter of digging out the switch here, which is buried under this cowling, and it's all got to come apart. Okay, so I think the short answer on this is we'll leave this radio alone. It's got a whole bunch of capacitor work in it. Something else is wrong with it, we don't know what. But I think it's worth exploring anyway, just to see where we're at with it. So that's the story. So the story is, what is the story? The story is the other radio is going to work if you put a functioning vibrator into it. And all it really needs from there is just a little bit of maybe tuning up. I'm not sure it's worth trying any other component changing in it. Yes, it has some older capacitors, and it looks like the B plus leakage is a little high. Might want to think about that a little bit. Might want to think about changing a couple of these remaining capacitors. I got this thing all undone. Not quite. There we go. But I think we're going to concentrate on one only. Great thing is we have another set of tubes. There we are. Okay. I think that's where it's gonna end today. Tomorrow, I think I can power up this radio and we can experiment a little more thoroughly with how well it works, and we can check the what was I going to say? Check the sensitivity of the radio, and then we can start fooling around with its alignment a little bit. There's quite a few things we can do while the new vibrator winds its way here. Great. Okay, so quite a few things there. Thanks a lot for watching, and see you on the next video.